This is SpaceTime Series 26, Episode 154, for broadcast on the 25th of December 2023. Coming up on SpaceTime, the Sun unleashes its biggest solar flare in years. The Webb Telescope takes another look at the ringed world of Uranus. And the Fermi Space Telescope creates a 14-year time-lapse of the gamma-ray skies. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
The Sun has unleashed its biggest solar flare in years, a massive X 2.8 blast of energy which slammed into the Earth, triggering 2 hours of deep shortwave radio blackouts across the Americas. Scientists with the National Oceanic and Atmospheric Administration, NOAA, say this blast was the strongest so far during the current Sun solar cycle, and the biggest since the great solar storms of September 2017. NOAA's Space Weather Prediction Center says it caused extensive radio interference affecting even the higher frequencies and resulted in the largest solar radio event ever recorded. The blast occurred in the far northwestern sector of the Sun's visible surface and was captured by NASA's Solar Dynamics Observatory spacecraft, which is constantly monitoring the Sun. Our local star, the Sun, goes through a regular 11-year solar cycle, during which it increases in activity and violence, culminating with the Sun's magnetic poles flipping polarity. The Sun's north pole becomes south, and the Sun's south pole becomes north. For this current solar cycle, number 25, the change in polarity, known as solar maximum or solar max, is expected to take place sometime during 2025. Solar flares are powerful bursts of energy erupting from the Sun's surface. They're triggered by snapping magnetic field lines, which extend from deep within the Sun out through its surface at locations known as sunspots. These loops of magnetic field then extend out into space into the Sun's corona before returning back below the surface. As the Sun is a huge ball of plasma rather than a solid object, different parts of the Sun are rotating at different rates. Consequently, the magnetic field lines tend to get twisted and eventually snap, and that's what triggers a solar flare. Really powerful solar flares can also cause coronal mass ejections when not only energy but also plasma from the Sun itself are flung into space. The recent record-setting X 2.8 blast erupted out of an unstable sunspot known as AR 3514. These eruptions, be they solar flares or coronal mass ejections, are what astronomers refer to as space weather, and they trigger geomagnetic storms as material from the Sun is flung towards the Earth. When this material hits the Earth's magnetic field, particles can flow along the Earth's magnetic field lines towards the north and south magnetic poles. This causes the spectacular northern and southern lights, the aurora borealis and aurora australis. But they also impact radio communications, electrical power grids on the surface, navigation signals, and they pose risks to spacecraft, damaging or even destroying delicate electronics. And they can limit a spacecraft's life in other ways by causing the Earth's atmosphere to expand and contract like a wobbling jelly blubber. When the Earth's atmosphere expands, it causes additional atmospheric drag for orbiting satellites. They then need to use more fuel in order to maintain an operational orbit, and the more fuel they use, the shorter their lifespan. Worse still, astronauts aboard orbiting spacecraft are also subjected to increased doses of radiation, an unhealthy scenario best avoided. Solar flares are classified by their strength, ranging from the weakest B-class events through C, M, and finally the strongest group known as X-class. Each increase in alert classification involves a tenfold increase in energy. The classification scale is further divided into numbers from 1 to 9, 1 being the weakest in the class, 9 the strongest. As the Sun continues hurtling towards the peak of its current 11-year solar cycle, scientists expect more powerful X-class flares to occur. We'll keep you informed. This is SpaceTime. Still to come, NASA's Webb Space Telescope takes another look at the ringed planet Uranus, and the Fermi Space Telescope creates a magnificent 14-year time-lapse of the gamma-ray sky. All that and more still to come on SpaceTime. NASA's Webb Space Telescope has again trained its sights on the distant enigmatic world of Uranus. Webb has already observed the ice giant, which spins on its side earlier this year, and has gone back for a closer look at this dynamic world, with its rings, moons, storms and other atmospheric features, including a seasonal polar cap. The new image expands on the earlier observations, adding additional wavelength coverage for a more detailed look. With its exquisite sensitivity, Webb captured Uranus's dim inner and outer rings, including the elusive Zeta ring, an extremely faint and diffuse ring closest to the planet itself. It also managed to image the planet's 27 known moons, even seeing some small moons within the rings themselves. When viewed in visible wavelengths as seen by the Voyager 2 mission back in the 1980s, Uranus appears as a placid, solid blue ball, silhouetted against the velvet black background of space. Webb is revealing a strange and dynamic world filled with exciting atmospheric features. One of the most striking of these is the planet's seasonal northern polar cloud cap. Compared to the Webb images from earlier in the year, some new features in the cloud cap are clearly visible in the new images. These include a bright white inner cap and a dark lane at the bottom of the polar cap towards the lower latitudes. Several bright storms can also be seen near and below the southern border of the polar cap. The number of these storms and how frequently and where they appear in Uranus's atmosphere could be due to a combination of seasonal and meteorological effects. The polar cap appears to become more prominent when the planet's pole begins to point towards the sun as it approaches solstice and receives more sunlight. Uranus reaches its next solstice in 2028, and astronomers are eager to watch out for any possible changes in the structure of these features. Webb will help disentangle the seasonal and meteorological effects that influence Uranus's storms, which are critical to helping astronomers better understand the planet's complex atmosphere. Because Uranus spins on its side with a tilt of about 98 degrees, it has the most extreme seasons in the solar system. For nearly a quarter of each Uranian year, and yes, that's how you say it, the sun shines over one pole, plunging the other half of the planet into a dark 21 Earth-year-long winter. Uranus can also serve as a proxy, allowing scientists to study the nearly 2,000 similarly sized exoplanets that have been discovered over the past few decades. This can help astronomers understand how planets of this size work, what their meteorology is like, and how they formed. And of course, this can also help astronomers better understand our own solar system as a whole by placing it into a larger context. This is SpaceTime. Still to come, NASA's Fermi Space Telescope creates a unique 14-year time-lapse of the gamma-ray sky. And later in the science report, a new study shows how humans have helped wipe out some 1,500 bird species over the past 100,000 years. All that and more still to come on SpaceTime. Scientists using NASA's Earth-orbiting Fermi Gamma-ray Space Telescope have created a 14-year time-lapse video of the gamma-ray sky. The spectacular movie, which is available on both the SpaceTime Tumblr and X blogs, shows the bright, steady gamma-ray glow of our Milky Way galaxy. The glow is punctuated by pulsars within the Milky Way, neutron stars rotating like lighthouse beacons. Also visible are intense days-long flares of near light-speed jets powered by supermassive black holes at the cores of distant galaxies. Senior staff scientist Seth Dalgall from the Stanford Linear Accelerator Center's National Accelerator Laboratory in Menlo Park, California, who compiled the images into a movie, says these dynamic eruptions, which can occur anywhere in the sky, actually happened millions to billions of years ago, but their light is only just now reaching Fermi. Gamma rays are the highest energy form of photons of light. The Fermi movie shows the intensity of gamma rays with energies above 200 million electron volts. These were detected by Fermi's Large Area Telescope, the LAT, between August 2008 and August 2022. For comparison, visible light has energies of only between 2 and 3 electron volts. Also visible in the movie is the steady, constant arc of the sun as it moves across the sky. The Large Area Telescope detects our sun thanks to accelerated atomic nuclei particles called cosmic rays, which are travelling at close to the speed of light. At times, the sun suddenly brightens thanks to powerful solar flare eruptions or coronal mass ejections, which can briefly make it appear as one of the brightest objects in the gamma-ray skies. The movie also shows the gamma-ray sky in 2 different views. There's a standard entire view, which highlights the central plane of the Milky Way, glowing brilliantly in gamma rays produced from cosmic rays striking interstellar gas and starlight. This is also flecked with many other sources, including neutron stars and supernovae remnants. Above and below the central band of the Milky Way is the deep universe beyond our galaxy, which appears peppered with bright, rapidly changing sources. Most of these are actually distant individual galaxies. They can often be better seen in the other view type, that which centres on our galaxy's north and south poles. Each of these galaxies is a blazar, powerful beam of energy and gas shooting out from a central supermassive black hole. These supermassive black holes can have masses of millions to billions of times more than our Sun. They produce extremely fast-moving jets of matter and energy. With blazars, we're looking almost directly down the throat of one of these jets, a view that enhances their brightness and variability. And those variations are important because they tell astronomers a lot about the jet's characteristics. Fermi scientists routinely watch these sources, and they then alert other astronomers to turn their telescopes towards them when something interesting is going on. In this way, Fermi plays a key role in the growing network of missions working together to capture these changes in the universe as they unfold. And many of these galaxies are an extremely long way away. For example, the light from one blazar in the movie, known as 4C plus 21.35, has been travelling for some 4.6 billion years, which means that the flare that we see today actually occurred just as our Sun and solar system were beginning to form. It's literally as old as the Earth. Other blazars are almost twice as distant, and together they're providing a striking snapshot of black hole activity throughout cosmic time. Not seen in the time-lapse are the many short-duration gamma-ray events that Fermi studies, things like gamma-ray bursts, the most powerful cosmic explosions since the Big Bang. They're not included because they're too ephemeral, not lasting long enough to be captured in the time-lapse images. More in this report from NASA TV.
14 years of observations collected by the Fermi Large Area Telescope, or the LAT. This is the primary instrument on the Fermi mission, and it surveys the entire sky every few hours. This allows it to do a lot of really cool things. It can look at sources that vary on timescales from a fraction of a second to years on end. The Milky Way and the gamma rays looks kind of similar, except we're looking at a number of different types of objects. In this map of the gamma ray sky, what we're seeing are actually intensity maps. Fermi isn't an imaging instrument like you think of Hubble or Webb. What it is it's actually a photon collecting instrument. It's a particle detector in space. And we make these maps by adding up all of the photons we collect. Our eyes don't see gamma rays. Most of those are pulsars. These are rapidly spinning, dense stellar remnants called neutron stars that are actually varying, pulsing on timescales from hundreds of times per second to several seconds. We see sources above and below the galactic plane. Those are largely blazars. What that is a supermassive black hole, millions to billions of times the mass of our sun, the center of a galaxy, that is active. That means that there's gas and stars falling into it, and it produces jets of emission, and they're very chaotic systems. So they're turning on and they're turning off. We have a team of dedicated scientists, what we call the flare advocates. Their job is to look at data every day that comes from Fermi and look for these flaring sources. It's not just so that we know that they're there and that we catalog them, but some sources are interesting enough that we want to tell our friends, other space and ground-based telescopes, that they should go look at the same place and collect multi-wavelength data so that we can better understand these outbursts. One source that isn't like the others, it's actually moving. and sometimes it gets brighter or fainter. That's actually just the sun. The sun is an interesting source in the gamma rays. It's not the brightest source in the sky like it is in the optical, but it's prominent in its quiescent state, where we're just seeing cosmic rays interacting with the solar atmosphere. We also see it when there are solar flares. There's a lot of variations in the sky over time. It's not the galaxy itself is getting brighter or fainter. It's that as Fermi surveys the sky, it doesn't do it completely evenly. Over many years, we accumulate a very nice, even exposure of the sky. But when we look at short time scales, what we're seeing are variations in the survey, not actual variations in the sky. The sky exposure pattern seems to change a bit starting about 2018. This was due to a hardware issue where one of our solar panels stopped rotating. It's still fully functional, and Fermi has enough power to operate both instruments and the observatory. What it means, though, is that the way we observe the sky and the timescales in which we survey have changed a bit. In our 14-year map, there's over 7,000 total sources. Almost 4,000 of those are these active galaxies, these blazars. There's several hundred pulsars, and in total, something like 2,000 of these sources are variable. This video showing the first 14 years of Fermi observations is just the beginning. Fermi continues to observe the dynamic sky every day, and we hope it'll continue to do so for many years into the future.
And in that report from NASA TV, we heard from Fermi Deputy Project Scientist Judy Rakusin from NASA's Goddard Space Flight Center in Greenbelt, Maryland. This is Space Time. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. A new study warns that humans have wiped out roughly 1,500 bird species in the last 100,000 years, with most being killed off just in the last 10,000 years. The findings, reported in the journal Nature Communications, are about double the previous estimates. The authors found the extinctions are mainly due to humans wrecking bird habitats, eating birds, and introducing invasive species. The research is based on fossil evidence from the late Pleistocene era between 126,000 and 12,000 years ago, and from the Holocene period over the last 11,700 years. Previous studies had been focusing primarily on extinctions over the past 500 years. But this team also looked at the fossil record of extinctions on islands, including New Zealand, and they estimate that around 1 in 9 bird species have gone extinct since the late Pleistocene. That's 55% more than previously acknowledged. They also found that big waves of extinctions in the Pacific coincided with humans arriving and spreading there around the year 1300, when rates of extinctions were some 80 times above the norm. The authors emphasize that their numbers are only a rough and ready guide, and they say the real rate of extinctions is sadly likely to be even higher. Scientists have found that a protein in the human immune system, which is programmed to protect the body from fungal infections, is also responsible for exacerbating the severity of some autoimmune diseases, such as irritable bowel disease, type 1 diabetes, eczema, and other chronic disorders. A report in the journal Science Advances by researchers from the Australian National University says the discovery could pave the way for newer, more effective drugs without the nasty side effects of existing treatments. The authors say that in addition to helping manage severe autoimmune conditions, it could also help treat all types of cancer. Scientists have found that the brains of people suffering from post-traumatic stress disorder or PTSD process traumatic events differently than sad non-traumatic memories. A report in the journal Nature Neuroscience recruited 28 participants with PTSD and scanned their brains with MRI machines while they listened to 2-minute narrative clips of their own memories, either traumatic memories, sad but non-traumatic memories, or calm memories. They found certain parts of the brain processed sad and traumatic memories differently, especially areas involved in processing traumatic memories in PTSD. The authors found they were even able to decode whether sad or traumatic memories were being reactivated simply by looking at the brain responses. About this time of the year, during what journalists like to call the silly season, media, especially those on the more tabloid end of the scale, tend to invite fortune tellers and psychics to make their predictions and forecasts for the coming year. The trouble is, they never bother checking back to see how accurate those forecasts really were. Well, Tim Mendham from Australian Skeptics does, and it turns out the success rate of psychics and fortune tellers is actually worse than simple guesswork.
It's always fun to look at psychics' predictions and actually go back to them a year later and see how accurate they were. It's often not the case. I mean, you find it all the time in magazines and TV shows and things. You get a psychic on in January and they say, this is what's going to happen over the next year. And they don't go back to them and check later on and say, you got the wrong. They just let it run, and then the next January they'll make some more. But skeptics being skeptics sort of a real party poopers, and we do that. There's a website called Higgy Pop which investigates paranormal, and a lot of the stuff is pro-paranormal, but then they throw in the skeptical side of things. And this is one they did their own little survey. It's only small, wasn't particularly big. They had 110 predictions at the start of 2023. They found out that very few of them turned out to be correct. And
I'm shocked.
That's as far as we can go as far as an actual number of how few. But then they go on to say that some of them were interesting and sort of not that close.
So that means
the usual thing.
Prediction was broad enough to cover a whole range of possibilities.
Yep. Paul McCartney will be in the news. The royal family, Prince Harry, will have a spotlight on him. No, they're actually saying that something huge is coming out about the royal family, which will take the spotlight off Harry. That's quite the opposite of what happened, actually. But never mind.
And, that would be
the royal
Meghan
family.
Markle. She's wanted the spotlight off Harry for a while.
There's always royal family things. Amazingly enough, a lot of people predicted problems in the Ukraine, seeing as the war had already been going for a year by that stage. And the problems with Rishi Sunak as British Prime Minister, that there would be a general election called and Labor would take over. There wasn't. There'd be a robbery in the centre of Edinburgh, very close to Princess Street.
No.
Really? If you've been to Princess Street in Edinburgh, you know it's pretty busy. There's lots of shops. And if there isn't a robbery there, you'd probably be surprised. And lo and behold, there was a robbery there, but sort of, okay. What else was there? There was Hawaii would be destroyed by a volcano. I think that would surprise a lot of people in Hawaii.
They're the sort of definitive ones. People are really, staking their reputation there.
They're the ones that, if it comes true, that'll be their whole reputation for the rest of their life.
Exactly, yeah.
Like the psychic who predicted the assassination of Kennedy. About 5 years before, when Kennedy was lesser known, a president will be assassinated, which is a fairly good guess. It wasn't bad, that prediction, and the fact that everything else she said was wrong over the years, she was still dining out on that one particular prediction. Amongst the other predictions, they were described as less accurate, meaning wrong. Donald Trump will be assassinated, earthquake will hit the Mediterranean, Pope dies in October, a health scare concerning eggs, which is a bit broad.
Well,
somewhere in the world,
are a source of salmonella, so yeah.
Yeah, well, probably somewhere in the world there's a problem with eggs.
Yeah.
Global food shortages,
Yeah, well, that
has been for a long time.
That happens all the time.
Yeah. Twitter will become unresponsive early in 2023. This
is after it became X?
Not X, but certainly after Elon Musk took it over and started cutting back on everything. I think it was X was earlier in the year. But anyway, and we'll be gone by the end of the year. Well, not, a lot of people left.
Actually,
but it's
technically
still
it is. It's now X. So
Oh, true. But yeah, okay, so they had a number of predictions that were sort of half right. Because the skeptics, being the biggest party poopers in the world, we did a survey a number of years ago in which over a period of 21 years we looked at predictions. We looked at predictions from 2000 to 2020. Virtually every prediction we could find done by a psychic or some such astrologist or whatever over that period in Australia. So it's magazines, TVs, radio, websites, you name it. We found 3,800 predictions, which is a lot better than the 110 this website did, but that was only 1 year after all.
Yeah.
And the accuracy rate was 11%. It involved over 200 psychics. Some of them made one prediction, some of them made hundreds, all sorts of different things. But yeah, 11% right. And even those right were not really good right. They were sort of, okay, we'll give them that one. But they missed out so many big stories that they should have got, funnily enough. That means their psychic antennae weren't working on.
It's a bit like firing a shotgun at a target, isn't it? One of the pellets is going to hit the bullseye.
That's right, yeah. And that's what they did. They had 1 in every 10 hit the bullseye. The industry's not very good at making predictions, but they still churn them out, and the newspapers and things still report them
and so
every year.
Because they are entertaining.
They are entertaining, but there are people who base their... a psychic will make these ridiculous predictions out there about global activities, but they are selling their services to individuals at the same time, right?
Yeah,
and they will make predictions about that individual. And I know people, and I know of people, who have spent tens of thousands of dollars and broken up families and do all sorts of things based on the predictions and prognostications of a psychic.
That's Tim Mendham from Australian Skeptics. that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.